Okay, so the last section we covered focused primarily on tangents, lines tangent to circles and circles tangent to each other. This section will focus on arcs and central angles. The first video will help you learn some new terminology and notation. The two videos that follow will focus on postulates and theorems that will be helpful when problem solving. So let's begin this video by looking at some new vocabulary. All right, so to begin, I'm going to focus on this first definition that we see, and that is central angle. So a central angle is an angle with its vertex on the center of the circle. So if we look at the diagram on the right-hand side here, I'll pick a different color. O is the center of this circle. Angle AOC has its vertex at the center of the circle, so angle AOC would be an example of a central angle. Okay. Or we could also call that angle COA. Now, an arc, on the other hand, is an unbroken part of a circle. So again, I'm going to grab the pen. Now, this diagram here, it's highlighted in red, but I'm going to highlight it over here as well in blue. Okay, this is an example of an arc of a circle. Now, there's different types of arcs that we're going to study. Okay, we've got the semicircle, we've got the minor arc, and we've got the major arc. And there's differences between each of them. So the notation that we're going to use is going to be similar for each, but there's going to be subtle differences that we have to take a look at and understand. So when we see the notation being used, we know if we're dealing with a minor arc, a semicircle, or a major arc. Now the notation, just kind of the overall notation, is kind of like a line segment, except we're going to use an arc. And underneath that, what we're going to do is either put 2 or 3 points that are the end points of the arc, and depending upon what type of arc it is, maybe an additional point as well. And we'll talk about that as we kind of progress our way through the notes. So what I'm actually going to do is I'm going to go out of order a little bit here, and I'm going to go to the minor arc. Actually, no, we'll do semicircle. All right, so the semicircle is an arc whose endpoints lie on the diameter of a circle. So if we look at this diagram that I'm highlighting right here, I'm circling in yellow. Okay, there's actually 2 semicircles in that diagram, and I'm going to highlight those for you right now. Okay, so we have this one that I'm highlighting in blue, and then this other one that I'm highlighting in purple. All right, now the reason that we can tell this is a semicircle is, again, first off, by definition, the endpoints of the arcs are on the diameter of a circle. And also the central angle that forms that semicircle is 180 degrees. Okay, so if the central angle is 180 degrees, the corresponding arc is going to be a semicircle. Now, if we want to use the notation, the shorthand notation from above, to talk about these 2 semicircles, we'll talk about the blue one first. So we're going to use the endpoints, so A and B, and then a point that the arc passes through, so we know which one that we're talking about. Let me just do this over again. All right, so ACB would be the arc that's labeled or highlighted in blue in the diagram on the right. You could also call that BCA. That would be appropriate as well. And this would be the blue arc. And then the purple arc, that would be ADB. And again, you've got the 2 endpoints, and then the point that the arc passes through. This would be the purple arc. So again, semicircle, an arc whose endpoints lie on the diameter. The measure of a semicircle is going to equal 180 degrees. And also the measure of that central angle is also going to equal 180 degrees as well. And we're going to talk about this further as we kind of progress through the notes. Now, minor arc. Okay, I'm going to highlight a second diagram that we'll work with. All right, this time it's going to be highlighted in blue. All right. So if you read the definition, it says an arc that is smaller than a semicircle. So what I'm going to do here is I'm going to call the center of this circle O, and then I'm going to draw in a radius to point C. And what I've actually done is created a couple semicircles. Okay, I've created, I'm sorry, minor arcs. I think I said semicircle, but I meant minor arc. Let's try this again. Okay, so there's one minor arc. And then here is a second minor arc. Now, when we name minor arcs using the shorthand notation, we're going to do that differently than the way that we named semicircles. All right, all we have to do is use the endpoints. So in this case, arc BC, that would be the purple arc. Arc AC would be the yellow arc. And again, both of these are examples of minor arcs. Now, we can tell that, again, a minor arc is a minor arc because the central angle that corresponds to that minor arc is going to be less than 180 degrees. So it's either going to be an acute angle or an obtuse angle. And then finally, a major arc. So a major arc is larger than a semicircle. So again, in here, I'm going to put the center of the circle is O, and then draw in the radius OD. Now I'm going to take my highlighter and I'm going to highlight a major arc using the green highlighter. So that right there would be an example of a major arc. So if you look, the central angle that's created there, so this right here, that angle is clearly larger than 180 degrees. Okay, so that arc would be a major arc. Now, the way that we're going to name major arcs is actually the exact same way that we name semicircles. So we're going to use that 3-letter notation. So again, the endpoints will appear on the end. So in this case, B and D are the endpoints. And now we just need to pick a point that's on the arc that's between points B and D. So in this case, we actually have two choices. We have C that we could use, or we could have A. So BCD would be an appropriate name for the arc that's in green or highlighted in green, or BAD would work as well. Okay, so again, there's 3 different types of arcs that we're going to study. We've got semicircles, minor arcs, and major arcs. The way that we identify those is really based on the measure of the central angle. Okay, so if the measure of the central angle that corresponds to that arc or creates that arc is equal to 180 degrees, then you've got a semicircle. If the central angle that creates that arc is either an acute angle or an obtuse angle, so less than 180, then you're dealing with a minor arc. And if the central angle is larger than 180 degrees, then you have a major arc. Let's look at a couple more terms here. So adjacent arcs are just arcs that have exactly one point in common. So again, if we look at this diagram, I'll grab the highlighter. Okay, so IJ and JK would be classified as adjacent arcs because they share exactly one common point, and that is point J. So IJ, arc IJ, and arc JK would be one example in this diagram of a pair of adjacent arcs. Now, congruent arcs are arcs in the same circle or in congruent circles that have equal measurements. So in this diagram, again, the same 2 arcs, IJ and JK, would be congruent. And we would mark the diagram in a similar fashion to the way that we've marked diagrams before. So if segments were congruent, we would use a little tick mark to show that those segments were congruent. So in this case, we'll do the same thing for congruent arcs. And the notation that we use is going to be exactly the same as well. So ij is congruent to jk. So again, very similar to what you've seen in the past. All right, now what I'm going to do here is I'm going to let you try these examples on your own. I've posted the answers to these to Google Classroom. So I'm going to have you check your answers on Google Classroom. I'm going to end this video right here, and I'm actually going to start the next video on the arc addition postulate, where we're going to start looking at some postulates and theorems that are going to be helpful for us when we start solving problems. I hope this helps, and we will talk to you soon.